This is an extension of Activity 1 where we looked at this number line. And what I wanted to do is extend this activity to make a connection between looking at the number line and actually calculating the slope of a line that has this length along the horizontal length, the horizontal length of a slope triangle. So we just looked at what's the difference between 12 and -4, and it's these 16 units. It takes 16 units to go from this -4 to this +12. So the difference between 12 and -4 is that 16. And once you start to write this as 12 plus a +4, you kind of lose sight that it's the length from this -4 to this +12. That's the difference between them. And you start looking at it as 12 plus 4 units. Well, it's interesting in that that is exactly what we do when we start calculating the slope and moving the slope triangle around. So here's that same length along the horizontal length is from a -4 to a +12. So that is that same 16 units. And to complete the slope triangle, the vertical length is from -3 to +5. And so you're going to see that that's 8 units, and the units along the horizontal length are 16 units. So if we write those 2 points, 12, 5, so go out here to 12, it's along the x-axis, and 5 units along the y-axis. So this point right here is at 12, 5, and this point here is at -4, -3. So -4 units, -3 units. So what's the slope? Well, that's the length along the horizontal axis and the length along the vertical axis. So it's the length along the vertical axis divided by the length along the horizontal axis. So how do you calculate those lengths? Well, the length along the vertical axis is the +5 minus this -3. It's the difference between +5 and -3. So the difference between +5 and -3, and the horizontal length is the difference between 12 and -4. So that subtraction symbol means the difference between them. So if we do that calculation, so 12 plus a +4, so it's the inverse operation, and the additive inverse, so 12 plus +4 is 16, and 5 plus a +3 is 8. And that gives you the slope of 8 divided by 16 equals 1/2. And that's shown right here. Here's the vertical length is 1, the horizontal length is 2, so 1/2 is 1/2. And if you look at sliding the slope triangle along the horizontal axis, we actually do, interestingly, go out to this 12 and add 4 more units to it. We slide this over 4 units. So this length along the horizontal axis is 16, and it matches the x-coordinate on this slope triangle once we slide it over. That's why we slide it over. It is the length along the horizontal axis, and it is the x-coordinate. And then we slide it up 3 units. So we're at +5 right here, and we're going to slide this up 3 units. So that's 5 plus 3 is that total of 8 units. So the vertical length, so I slide it up, the vertical length then is what's the difference between +5 and -3? Well, it turns out to calculate that it's 5 plus a +3. So we're at 5, and we add that 3, we slide it up. So we're actually, to find the difference, or find that length, we're actually using the inverse operation and the additive inverse to calculate those. So inverse operation and additive inverse. Inverse operation and add the additive inverse. And so that moves this blue slope triangle to this point right here is now at 16, +8. And because you're starting at 0, 0, the x-coordinate is 16, the y-coordinate is 8, and so the slope now is just the y-coordinate over the x-coordinate, or 8 over 16 equals 1/2. So that's the connection, and that's what you're going to do a lot as we continue with math, is to calculate the slope. You're going to find the difference between 2 points, and you can imagine or you can visualize sliding these triangles around.